Okay, so we talked about power functions. Now I want to talk about even power functions. Go ahead and look on your calculator. Go ahead and graph x squared, and then x to the 4th, and then x to the 6th. So take a minute, graph that, pause, and come back. So if you've graphed them, and you can have graphed them all on one graph or 3 separate graphs, what I want to know is, what are the similarities? What did you see there? Well, if you look at the graph, I can just sort of estimate what it looks like. X squared looked like that, right? X to the 4th maybe look like that, and x to the 6th look like that. So you see how it's growing faster. But they all have the same shape. They all have this U shape. So they have the similarities, or they have the same shape. If I'm just graphing x squared, x to the 4th, they all have the domain of all real numbers. And my range is y has to be greater than or equal to 0. So there's no negative numbers. They all are at 0 and they increase, right? They both go to infinity. They kind of look like someone with, the 2 arms held up. So let's look at the properties of even power functions, knowing that. We also see, when we talked about symmetric, so the graph is symmetric with respect to the y-axis. We also know, as we said before, the domain is the real numbers. The range are non-negative real numbers. They always contain the points. Zero, 0, 1, 1, and negative 1, 1. And as x increases, as n increases, right, in magnitude, the graph is steeper. For x less than negative 1 or x is greater than 1. But near the origin, it flattens out. It tends to flatten out and lie closer to the x-axis. And what you should do to see that is go into your function and change your window. So x is between, as you can say, negative 2 is less than x is less than 2. And maybe y also the same. And you can look at what happens, and you will see what it looks like. So go ahead and do that. And those are basically even power functions.